Yeah, so I think one of the challenges with large amounts of data, which is really being driven by the monitoring of the physical and the virtual world. So if you think about the virtual world, you've got a vast array of containers and servers and disk arrays and all the manner of IT components that people are dealing with. And that is clearly not slowing down. And whether you've deployed it on-prem or in the cloud, if you're trying to monitor that kind of environment, you're just dealing with an ever-growing number of those things. And of course, one of the challenges, you'd like to be able to do trend analysis, you'd like to be able to take immediate action when problems occur, and the vast majority of data systems that exist today are not really set up to ingest and analyze that data at speed. And of course, one of the unique things about time series data is the value of that data from a precision perspective tends to go down over time. And so you both need to be able to ingest and analyze that data at high speed, as well as evict that data or downsample it to some other degree so that you can leverage that for the long-term trend analysis. And again, relational systems aren't really set up to do that. Hadoop tends to be very slow. While you can gather and land all of that data, your ability to analyze it at any sort of speed and scale is really for more historical reporting purposes. And not really to take immediate action. And so I think that's one of the things about a purpose-built time series database that's so unique and so valuable in the context of not only the server monitoring use case, but now as we turn our attention to the instrumentation of the physical world, sensors everywhere, and whether it's consumer electronics or something in the industrial space, you're going to be faced with those same kinds of challenges as well, which is vast arrays of data coming at very high speed and needing to take action on it in real time. So at the core, we sort of built an ingest pipeline that will allow you to gather and shape that data in a way that will be tremendously useful upstream. And so that's one of the things we're focused on. Second is we've really shifted from trying to keep all of that data indexed in memory and to allowing it to index and spill to disk, those index elements, to allow for the queries to continue to perform, but also to allow for a much larger cardinality, which is sort of the variety of the data that you're receiving in. Yeah, so this has been tried, many times, right? And so our founder, Paul Dix, really started with this on Wall Street, looking at how he might sort of create a layer on top of a more traditional columnar data store, like a relational database, or even using some of the more modern NoSQL technologies. And the reality is it's always a Band-Aid around problems that exist at lower levels. And so in the invention of Influx and sort of thinking about the problem at its core, that's really what we've been built around. I think one of the questions when you're looking at time series data and where it lands is thinking about who the end consumer of the data ends up being. So sometimes that may be people in an operations environment who need visualization of, again, the trends or looking at alert conditions that may occur or detecting anomalies within the data that's being gathered. And the idea is you want that telemetry, that early warning system, to provide you visual insight into where to go in to take those actions. And ultimately what you're trying to do is automate those systems, sort of build automation around sort of unique conditions and challenges that occur. And again, that's no different in the DevOps landscape, in the IoT landscape, and in the physical world. And so, one of the things is we've tried to think about and build in the ease of embedding that technology in a way that can be used by end consumer people as well as people who are super deep in the technology. And so while primarily we talk to developers today, what we see them doing is enabling these super high value solutions and super visible solutions for a wide variety of users. And it's really incredible to watch that happen over time. Yeah, so again, I think the balance is on making sure you understand the use case for your data. So there's the near-term and immediate use to take action and understand where things may be going awry, and making sure that you can commit to service level agreements to your customers, your partners, your internal constituents. That's one aspect. And then the second aspect is how can you continue to leverage that data that you've already spent and landed on, but in a more meaningful way. You don't need that high precision data. There's only a very unique set of cases in the world where you need to keep that. One of our customers, CERN, is certainly one of those from a research perspective. They obviously want to keep that data forever, but in the vast majority of use cases, as you go through the process of looking at what users and use cases you're trying to support, that high precision data is needed, and that's a place where you can absolutely reduce your storage costs immediately by going through the downsampling process. Yeah, it becomes a question of who's the user, when do they need the data, what kind of actions do they need to take on it, and I think we've made it as easy as we can for customers to both ingest at that high rate of speed, as well as keep only what they need over time.